8.4. So this is the last video for the hints. Part 4 for two questions. Question number 23 and then number 24. All right. First, number 23. We did several similar questions before, and this one slightly different, but the way we handle it, pretty much the same. So look at the hint. Draw the diagram, 20% of the memory references. So that's our base. All right. So we assume 100 memory references or accesses, the same thing. All right. Among 100, we know 20%. So that's 20 data transfers. Remaining 80 instructions. All right, in this way. Then new technology apply, reduce the data misses. Here, remember, we are considered data cache, data misses. All right. If we know that for every 1,000 instructions, the new technology can reduce 15 data misses, how much can be reduced in miss rate? Reduction part, miss rate. Now, I think this part, reduction part, some of you may feel relatively hard to handle. So that's the new part of this question. All right, so first, miss rate representation. First, we need to consider the miss rate representation. Okay, for data cache. Miss rate representation for data cache. All right, So let's write this way by the definition of miss rate. Because new technology, older technology, so we need to write two versions. One version for old technology, one version for new technology. Then we take the difference. All right. So miss rate 1, R1, that's for old technology. Okay. R1 equals M1. Number of misses, right? M1, number of data misses. M1 over, now, denominator, number of memory accesses with respect to data cache in 1,000 instructions. In 1,000 instructions, how many data accesses? Okay, we know instruction data for 80 instructions, there are 20 data transfers. 4-to-1 ratio, right? 4-to-1 ratio. Okay, now if we have 1,000 instructions, number of data accesses, 1/4. 1/4. 1/4 of the instructions belong to data accesses for R1. Okay, R2, M2, same denominator. Okay, then we take the difference. Okay, R2 minus R1 equals M2 minus M1, same denominator. Okay, Now we know reduce 15 data misses. That's the reduction part, right? 15. And what is the reduction part of miss rate? You need to calculate the miss rate reduction part. Okay? Yeah. So that's the meaning. Yeah. So that's the key part of this question. Yeah. All right, so the last question for our hints, number 24. Yeah. So this question, I give you the environment analysis in a previous question, previous video. You can find the, basic environment analysis. Here, I just build on top of that. So I do not want to repeat that same environment analysis. All right, so I assume you have that background. So now we start from there. When we look at the average memory access time, remember there are two parts. Right? The first part, T average access time before instruction part. Okay, times the weight. Remember the weight. 100 over 100 plus x, right? Weight. Then the data part, average data x over 100 plus x. Okay, all right. Now, to set up equation, the given condition, ratio 3.6 to 1 ratio. Can you set up an appropriate equation to find x? This ratio, 3.6 to 1, but the expression, first expression, second expression. So that's the ratio of the time in two different caches. So don't forget to multiply their corresponding weights, fractions, weights. All right, so other than that, you just use the previous video to get the specific representation for instruction average memory access time, data average memory access time. All right, so that's the information I like to give you. Now, based on your understanding, you can complete all the questions. All right, so let's stop here.